Hello and welcome everyone to our 18th Fairwork webinar. Today, our partners from CRF and Flex will introduce their plan for the evaluation and what's the current status is of the evaluation and how we can use our democratic AI-based decision support system in their production sites. As a short reminder, what the project is about, the main goal is that we have a configurable and flexible decision support system which supports democratic AI-based decisions by offering a knowledge base, so saving data from the production lines and production environments in the knowledge base, which is then used with an orchestrator who is configured to use different AI algorithms and approaches to make complex decisions or support complex decisions in production environments. And today we will look at how we can evaluate if these AI services that we have already created as prototypes, how well they fit to really tackle the problems identified by our use case partners, which is Flex and CRF, and how well they want to evaluate how they can support and how well they support their decision making. This is a short introduction, and then I will hand over to our colleague Roland from Flex Althofen, who will introduce their part for what they've done in Flex Althofen. Roland, the stage
Okay,
is yours.
thank you, Christian. I want to present the use case from Althofen. Next slide, please. The name of our use case is AI maintenance support, and general information. So we have around currently 8,000 unplanned repairs per year in Althofen, a very huge amount related to the more and more complex machine and more processes. And this is a result that we have to use more and more inexperienced employees and this result then to, let's say, to longer lead times to fix the machine. And the idea of this AI tool is to support these employees to reduce the repair, and for sure this is a downtime where we cannot produce, and to have a quick support for maintenance personnel. Next slide, please. So the current situation is that we have a lot of different sources. The main source is the ISPRO-NG, which is our maintenance database and also used for the task ticket system, where the operator places a ticket if he has a problem, and then this is going directly to the maintenance guys to fix the topic. Then we have our wiki system where the maintenance engineer can collect informations about issues and how to solve it. And also we have then an additional database with manuals and specifications of the equipment. And one problem what we have, what I mentioned before, is less experienced people need support from experienced staff, and so we block these resources. And the target is here to create a knowledge database based of the above mentioned sources, and to bring up or to speed up, let's say, the activities of the maintenance team to fix problems earlier. Okay, next, please. So we had, let's say, the first prototype. We make a preliminary evaluation to get familiar with the system, and then we feed the knowledge database with all the relevant documents. First experience were carried out then with questions to the DAI-DSS tool, and in discussion with the global team to get the tool activated so that we can have access via company network, because it was blocked, and this is solved so far. And yeah, with the first, let's say, evaluation, small evaluation, we give the feedback to the project partners about these results. And based on this feedback, our partners developed a new, or let's say, modified AI tool. Next, please. So, and currently we are in this phase that we are starting with the second prototype, which is already developed. We have the plan that we make the first evaluation, small evaluations with 5 peoples. The first task will be that they ask really 10 identical questions in written or in spoken form. And the target should be 100% identical answers. Then we jump into the next step with, again, 5 peoples, can be the same peoples or different. This is still open. Ask freely chosen questions on the same topic. That means they can form their questions how they want, but with the same topic. And the target here should be that we get 80% right answers. And the third step is that 5 people can freely choose a problem, whatever they in their mind. And here is the target that we should reach 60% right answers. Next, please. Yeah, so the next step is if the first evaluation reached the goal, or what I mentioned before, then we want to roll out this tool to the entire maintenance team. And then we can check on let's say, on this higher amount of operators, if we have a reduction of the repair time in comparison to the past. And if this is not the case, if we reach not the targets, we have to go and feedback to the consortium with the problems, what we find out, or to discuss why we cannot reach our goals, and to fix these issues. Next, please. I think that's all from my side. Yes, and I want to hand over to Flex Timishwara, to GP, to introduce his use case or give a status about his use case.
Okay, hello, I'm Cipriano Alexandrescu from Flex Timișoara. So let's start the presentation. Christian, you can move to the next slide. Okay, the use case in Flex Timișoara, it was to verify of certification calibration. As a general presentation, all the certification of calibration received from the calibration service provider need to be verified for possible unconformity before to be uploaded in our quality system. What kind of unconformities is about missing or some wrong information about the equipment model, type, manufacturer, serial number or ID, calibration date, calibration result, issuer and approver signature, page numerotation, and so on. The verification or certification of calibration is a manual repetitive work, which time consuming, and of course, in the being a manual work, could be subject of human error. The proposed solution and benefit for that one is to develop an application based on a DAI-DSS algorithm, which to replace manual verification of critical information mentioned above with with an automatic solution. The AI tool to provide a report with all non-conformity found if exists such non-conformity. This results to a drastic reduction of verification time and of course eliminate human error. Next slide, please. The current situation is we have an average of more than 3,800 calibration certificates per year, received per year from the provider of certification of calibration, from which 3,100 is coming from 2 calibration service provider, which can be divided in 4 different category templates, which is much more structured. There are also a number of something than more than 700 coming from different sources, which are not structured, not respecting a specific template, which is out of the scope for the moment for this project. We have a split based on the percentage and based on the count of the certification of calibration. We see that we have, if you take a look to the the third main category, this will cover about 76% of total certification of calibration received, which is about 2,900 calibration certificate, which is, if you take a look to the possible saving, this means about 241 man-hour. It's like 30 working days per year. If you consider an average verification time about 5 minutes per calibration certificate. So it could be a quite good improvement if we succeed to solve these 3 main categories of structured certificate. Please to the next slide. So we received the first prototype from developer, and we have a preliminary evaluation of that one. This is also the first category, the main one, which is testing on accredited certification of calibration. It's the 28% from total number of certificates received in 1 year. First step, it was just to run a sample, a small sample size, few randomly choosing, because there is different type of equipment, and it was choose some randomly choosing certificates of different type, just to see the behavior output of the prototype in terms of stability and repeatability. When you run such a small batch, it was not see anything that to see that there is strange behavior or something like this. The result was according with the expectation. This means not to be pass or fail. It's just that even it was fail. When you look to the failures, it was expected failures. I'll explain later about this one. In step 2, it was running a large sample size. In fact, all the batch of 1,175 testing non-accredited certificates from the last year. Of course, there is a lot of failures, but most of them, the big part, it was so-called false calls, because there was some discrepancies between what it was written in our database, calibration database, and the way it was edited or issued by the service provider. Based on the result obtained, it was created a first draft of list with issue and enhancement issue that it was a real error, or enhancement that, to avoid false calls, and some enhancement that it was returning back to the developer to make some improvements in prototype. One of the main issue, it was a parsing error, which appear also when you want to create some not good create some not good certificate for tool validation, and also this parsing error appears for original some of the original certificate receive it. Then this one was the main issue discovered in the first preliminary evaluation. Next slide, please. When we received the prototype number 2, that one, it was also add a new category, the micro precision, which is another important category which cover 24% from total number of certification. And there was also correct the parsing errors detected in the first step or in the first evaluation, and also other minor improvements. For that one, we succeed to generate some not good and also good certification, and to apply the attribute study to verify from the MSA measurement system analysis technique to verify the correctness and repeatability of the software tools to ensure confidence and reliability levels of 90%, respectively 99%. It will use the following approach. The good and bad sample ratio, it was choosing to 50%. It was chosen 10 different type of equipment and certification of calibration, for which it was created for good samples, and also 10 with bad samples, for which it was create some known defects to cover all the user requirement specification, URS, as you call it. The number of upriser, the operator, it was 1 chosen, and the number of repeat, it was 23 to cover that confidence reliability level mentioned above. This means to run 230 inspection, total number of inspection of good defect, it was 230, minimum it was 229 according to technique use it, and similar for defect, similar for good parts. Conclusion after we ran this trial, it was the study. It was that the concept version of the software tool, it was working well, working expecting based on the given draft user requirement specification. That it was all what it was bad, it was bad or fail, or what it was good, it was pass. You can go to the next. So if you take a comparison to evaluation of prototype 1 and prototype 2, which is prototype 1, it's verification tool version 04, and prototype 2, it's verification tool version 07. Total number of tests was 1,175, the complete batch. When you take a look, not to the reliability, but to take a look to the complete batch, we identify some parser error. We can see that it was decreased the number of parser error. There is still something, and the team is working to fix that one. Number of failure, it's a huge number of failure, but this is not to worry for us, because behind of these failures, it was some real failures, and there is a lot of false failure, which it was already addressed, and most part of them, it was in progress to be solved. Number of passes is a small number of passes, but once again, it's not to worry for us. And we have also a table with to see based on each URS what it was the failures, in fact, and the explanation for that one. What is important to remark here is that the calibration certificates address a wide range of instruments and equipment, and not all the measurement details given the certification of calibration follow a well-established template. Then provider can provide information slightly different from the template. Then will remain some part of URS which all the time will be fail or will be induce some false fails, but this is something that we can assume. Then it's clear we're not expecting to have a 100% yield, but if you reach like 90%, it will be very satisfying. Okay, go to the last One, please. Then as a conclusion, we need to work in two directions to improve the yield. One, it's in the Flex side, it's to clean and better structure the certificate data calibration, certificate database for the certificate for calibration, because also there is some room for improvement and to standardize the information, how it is written in the database. And also there is some finding in the software tools as to, on the two direction, which is one, it's to improve the detection improvements. It's eliminate case sensitive. It's ignore spaces in front of or in the middle or at the end of the words that it's verified. If the document contain minus or double minus and the database contain not applicable, the result to be passed, because we have some information in database and the provider come not with a not applicable, come with a minus or double minus, which is the same meaning. That such things that need to be a little bit corrected, and it's expecting to have a huge impact in the yield. Also, there is some improvement in the output. Log file to be for pass to contain only a global result for pass, and for fail to have only the fail information, is to simplify how to read and to the contents of the log file. Also to create some folder for pass and fail certificates where to be moved once they are already processed. So we are expecting the third, which is the third prototype, which is ongoing, and to make more trials to see what is the results. So that's it from my side, from Flex Timișoara. You can go to my colleague from CRF, Alexandru, to present their use case.
Thanks, Cyprian. Okay, we can start.
Thank you.
I'm Cisi Alessandro. I work in CRF since 2006. I'm a specialist in systems for quality monitoring regarding both processes and products. Regarding our role in the project, we are the interface between the plant and the consortium. The case study is the press shop in Mirafiori plant in Turin. I briefly summarize the point of this presentation. The case study scenarios will be described. I will be quick on this aspect because they have already been explained extensively in the previous webinar. Then I will describe our experience in introducing AI services in the industrial environment. So how to introduce them, how to evaluate their effectiveness, and how to evaluate their impact on workers. Next slide, please. Okay, the first scenario is the production planning. The goal is to meet the customer orders in the quantities and deadlines requested without occupying the warehouses for too long. It is necessary to avoid inefficiencies. Therefore, on one hand, avoiding overtime, and on the other hand, avoiding that the lines do not work at full capacity. System must be able to react quickly to unforeseen events, and regarding the KPIs adopted to evaluate the system, we need fast reaction times, multiple alternative solutions. In the long term, we assume we can improve the line occupancy, consequently be able to have a saving in the energy consumed. Next slide, please. The second scenario is the workload balance. In this case, the target is to assign workers to the different lines based on the geometry produced at the moment. The assignment is not made based exclusively on workers' suitability, that is based on these medical conditions or ergonomic indexes, but also based on a multitude of other factors. For example, his experience, his preference, his resilience. The objective is to have a fair and balanced distribution of the workforce on the lines, improving workers' well-being and maybe reducing unplanned absenteeism. Slide, please. The last scenario is the delay of materials. Based on a specific request from the plant, our effort focused on the optimization of the truck's load. Another normally consists of more than 100 containers of different shape and different stackability based on the geometry they contain, and also the trucks that can be used have a different size and capacity. The target is to fulfill all orders with the best use of trucks, maximizing the load capacity, because it's not efficient to travel offloaded. By acting this way, we expect to improve the energy efficiency due to the orders delivery. Next slide, please. So about the first question, how to introduce AI services in industrial environment. I would like to underline two aspects. The first, of more technical nature, which concerns all the activities carried out so far in the project. At the current stage of the work, we have a few prototypes based on AI services. They take the plant data and suggest solutions for the three case study scenarios. We are now in the testing and validation phase. The second aspect regards the trust building. So explain to the plant management the project's purpose and the benefits that can be obtained. Involve them in all aspects of the project, for example, the identification of the most critical and interesting scenarios for the plant. Then analyze the requests, suggestions, and doubts. Next slide, please. About the second question, how to determine the effectiveness of AI service performance. This aspect is linked to the validation of the system, so the action we have decided to carry out. First of all, we want to do a usability test for the evaluation of the prototype interfaces. We will use two questionnaires. A quantitative test that defines how much volunteers are able to carry out the assigned task correctly, and a qualitative test that is about the feelings of the user using the interface. The users will be 10 volunteers from the CRF and will be assisted by a team of experts of 3 members. Then we have the decision-making model evaluation. The test method will be a comparison between the decisions taken by the press shop staff with those proposed by the decision-making model. In this case, for working, the working group is made by the plant management team with the support of CRF personnel. At the end, we will also have the long-term KPI evaluation. Next slide. Finally, about the question, how to evaluate the impact of introducing AI services in an industrial environment. Over the past months, we have conducted several interviews and open discussions with plant personnel, and we have collected their impressions and doubts. For example, we need to answer the question how to avoid bias, that is, how to avoid distrust towards this type of systems, how to avoid that the operator manipulates his preferences for unknown motives or inconsistent reasons. In addition to interview and open discussion with managers, we are thinking to use questionnaires like the qualitative tests previously described, and something like a counter to understand how many suggestions potentially correct are accepted or rejected. I think this is the last slide.
Thank you very much to the 3 presenters for their interesting insights into how they want to evaluate or already evaluated these AI services in their production lines. Are there any questions from the audience? Something that should be re-explained or explained in more detail? If not, then if there's nothing more, then thank you very much for joining our webinar. Our next webinar will be in mid of February, where our colleagues from RWTH will introduce the notion of democratic decision-making in fair work, which is also an interesting topic, but a more theoretical one. But till then, thank you very much for joining and see you next time. Bye.
Thank you. Bye-bye.